Hello, curious minds! Welcome back to Solar System's Wonders. Today, we're diving into Earth, but not in the way you might expect. We won't just be talking about the basics you learned in school. Instead, we'll uncover what makes our planet truly exceptional. Have you ever wondered why, despite discovering several Earth-like planets, none are known to support life yet? What makes Earth's structure and features so uniquely suited for life? And how many remarkable coincidences and specific conditions did we need to get our pale blue dot so special? Stick around as we explore the incredible factors that make our home a one-of-a-kind gem in our solar system. Our journey into Earth's uniqueness begins with where it all started, its place in the solar system. You see, Earth isn't just randomly placed, it sits in a region astronomers call the Goldilocks Zone. This zone, also known as the habitable zone, is the sweet spot around a star where temperatures are just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. As we know, liquid water is essential for life as we understand it. If Earth were any closer to the Sun like Venus, our water would boil away, creating a scorching and inhospitable environment. But if we were farther out, like Mars, our water would freeze, leaving our planet a barren wasteland. Earth's orbit within the Goldilocks zone as the third planet is just one piece of the puzzle, a crucial factor that sets the stage for the incredible symphony of life we see around us. Now imagine a world where days last for months, and nights stretch on for what seems like an eternity. That's the reality on some planets, but not on Earth. Our planet enjoys a relatively quick rotation period of about 24 hours, which is just right for life. This steady spin ensures that temperatures are distributed more evenly across the globe. One side doesn't get cooked while the other freezes. This balance is vital for regulating our climate and making Earth a comfortable place for life to thrive. This rotation also creates our day and night cycle, influencing everything from plant growth and animal behavior to weather patterns and ocean currents. It's a fundamental rhythm that shapes life on Earth in countless ways. So, while it might seem like a simple spin, Earth's rotation is anything but ordinary. Our planet doesn't just spin, it also dances around the Sun in a slightly elliptical orbit. And you know what? This elliptical shape is another factor that contributes to Earth's unique character. Because of this slightly oval-shaped path, Earth's distance from the Sun varies throughout the year. We're a bit closer during the winter in one hemisphere and a bit farther during the summer. These variations in distance are small and don't drastically affect our seasons. The tilt of Earth's axis plays a much bigger role in that. The important thing is that this elliptical orbit, combined with our Goldilocks zone location, helps maintain a relatively stable and moderate range of temperatures on Earth, perfect for life to flourish. When we think about life on Earth, we often focus on what's happening on the planet itself, but what's happening beyond our atmosphere is just as important. Luckily for us, Earth sits in a relatively safe zone in our solar system, shielded by two gas giants, Jupiter and Saturn. These massive planets, with their immense gravitational pull, act like cosmic vacuum cleaners, drawing in or deflecting comets and asteroids that might otherwise pose a threat to Earth. Think of them as our big brothers, watching over us and protecting us from the dangers lurking in the outer solar system. Without these planetary guardians, Earth would be a much more chaotic and dangerous place, bombarded by space debris much more frequently. So, while we might not think about Jupiter and Saturn every day, their presence has undoubtedly played a significant role in making Earth the safe and habitable planet we call home. However, it's important to note that while Jupiter and Saturn provide significant protection, they don't shield Earth from all space debris. Some smaller meteoroids and fragments still make their way to our atmosphere. To truly understand Earth's uniqueness, we need to rewind the clock about 4.6 billion years. Back then, our solar system was just a swirling cloud of gas and dust, a cosmic nursery where stars and planets were born. At the center of this cloud, gravity pulled material inward, compressing and heating it until a star ignited, our very own Sun. This newborn star, blazing with energy, illuminated the surrounding disk of leftover gas and dust, setting the stage for planet formation. As the Sun blazed to life, it created a powerful solar wind, a stream of charged particles that swept through the early solar system. This wind pushed lighter elements like hydrogen and helium further out, while heavier elements like iron and silicon remained closer to the Sun. This separation of elements played a crucial role in shaping the destiny of Earth. It's why our planet is a rocky world with a metallic core, rather than a gas giant like Jupiter or Saturn, which formed further out, where lighter elements were more abundant. With the Sun blazing at the center, the remaining dust and gas in the disk began to clump together. Imagine a cosmic game of marbles with particles colliding and sticking together, gradually growing larger and larger. These growing clumps, called planetesimals, attracted more and more material through gravity, eventually becoming the planets we know today. Earth too went through this process of accretion, gradually accumulating the material that would form its distinct layers and composition. But Earth's formation wasn't a peaceful process. The early solar system was a chaotic place, with planetesimals constantly colliding. One such collision, with a Mars-sized object called Theia, is thought to have been a defining moment in Earth's history. This cataclysmic impact, billions of years ago, is believed to have ejected a massive amount of debris into space, which eventually coalesced to form our moon. We'll delve into the moon's incredible influence on Earth a bit later. Now let's journey to the heart of our planet, where Earth's internal structure plays a crucial role in shaping its surface and supporting life. Earth isn't just a solid ball of rock, it's a dynamic and layered planet with a molten core, a churning mantle, and a thin, solid crust. At the very center lies the inner core, a sphere of solid iron and nickel, under immense pressure and heat, hotter than the surface of the sun. This extreme environment is crucial for generating Earth's magnetic field. We'll talk about it later. Surrounding the inner core is the outer core, a layer of liquid iron and nickel. This liquid metal, constantly moving due to Earth's rotation, generates our planet's magnetic field, a crucial shield against harmful radiation from the sun. Above the core lies the mantle, a thick layer of hot, dense rock that behaves like a very viscous fluid over long periods. The mantle is in constant motion, driven by heat from the core. This heat transfer drives plate tectonics, the movement of Earth's crustal plates, which shapes our continents, creates mountains, and triggers earthquakes and volcanoes. While Earth's core and mantle might seem hidden from view, their influence on the surface is profound. The dynamic duo of plate tectonics and volcanism, driven by Earth's internal heat, has shaped our planet's surface and played a crucial role in making it habitable. Plate tectonics constantly renews Earth's crust, recycling old crust back into the mantle and creating new crust at mid-ocean ridges. This process helps regulate Earth's temperature, preventing it from becoming too hot or too cold, and ensures a continuous supply of nutrients and minerals essential for life. Volcanoes, often feared for their destructive power, are also essential for life on Earth. They release gases from the Earth's interior, helping to form and replenish our atmosphere. Volcanic eruptions also bring valuable minerals to the surface, enriching the soil and supporting plant life. This dynamic interplay between Earth's interior and surface, driven by its internal heat, is a testament to our planet's incredible dynamism and a key factor in its ability to support life. Over billions of years, the combined forces of plate tectonics, volcanism, and erosion have sculpted Earth's surface into the diverse and ever-changing landscape we see today. Mountains have risen and eroded, continents have drifted across the globe, and oceans have opened and closed. These geological processes have not only shaped our planet's physical features, but have also influenced the evolution of life itself. The formation of mountain ranges, for example, created isolated environments where new species could evolve, while the movement of continents played a role in the distribution of plants and animals across the globe. Earth's geological activity is a constant reminder that our planet is not static but a dynamic and evolving system. It's a testament to the incredible power of nature and a key factor in making Earth the unique and vibrant planet we call home. Earth's gravity is another fundamental factor in its habitability. Our planet's gravity is strong enough to hold on to a stable atmosphere and liquid water, but not so strong that it would crush life or pull everything into an inescapable gravitational well. This balance is perfect for maintaining life as we know it. A planet with too much gravity would have an atmosphere too dense for life to thrive, while one with too little gravity might not retain a stable atmosphere or liquid water. Earth's gravity, combined with its size and mass, ensures that we have just the right conditions for life to flourish. Let's take a deep breath and appreciate something we often take for granted: our atmosphere. This invisible layer of gases surrounding our planet is much more than just air. It's a crucial component of what makes Earth so uniquely suited for life. Unlike the thin, almost non-existent atmospheres of planets like Mercury, or the incredibly dense and toxic atmospheres of planets like Venus, Earth's atmosphere is a delicate balance. Our atmosphere is primarily composed of nitrogen, about 78%, and oxygen, about 21%, with trace amounts of other gases like carbon dioxide, water vapor, and argon. But it's this precise mixture, this Goldilocks blend of gases, that creates the perfect conditions for us to breathe, for plants to photosynthesize, and for our planet to maintain a stable and life-sustaining temperature. Our atmosphere isn't just about breathing, though. It also acts as a protective shield, absorbing harmful ultraviolet radiation from the sun and preventing extreme temperature swings between day and night. A key part of this moderation is the greenhouse effect. Certain gases in our atmosphere, known as greenhouse gases, trap heat from the sun, acting like a blanket that keeps Earth warm. This natural process is essential for maintaining temperatures that support life. Without it, Earth's average temperature would be around -18 degrees Celsius, far too cold for most forms of life. Earth's atmosphere and climate are not just about averages and long-term trends, they're also about rhythms and cycles that shape our planet's weather patterns and influence life in fascinating ways. Take, for example, the seasons. We often think of seasons as simply being warmer or colder periods of the year, but they're much more than that. They're driven by the tilt of Earth's axis as it orbits the sun, causing different parts of the planet to receive varying amounts of sunlight throughout the year. This variation in solar energy drives not only temperature changes, but also shifts in wind patterns, ocean currents, and precipitation, creating the distinct seasonal cycles we experience in different parts of the world. These rhythms and cycles are essential for life on Earth. They influence everything from plant growth and animal migration to the distribution of nutrients in the oceans and the availability of water resources on land. Earth is aptly nicknamed the Blue Planet because liquid water covers 71% of its surface. This water is constantly on the move, circulating between the oceans, atmosphere, and land in an intricate dance known as the water cycle. Imagine a single raindrop falling from the sky. This simple question leads us on an incredible journey following the water cycle, a continuous process that connects every corner of our planet. It all starts with the sun's energy warming the surface of oceans, lakes, and rivers, causing water to evaporate and rise into the atmosphere as water vapor. As this warm, moist air rises, it cools, and the water vapor condenses into tiny droplets forming clouds. These clouds, carried by winds, eventually release their precious cargo as precipitation: rain, snow, sleet, or hail. Oceans, the heart of the water cycle. Covering over 70% of Earth's surface, these vast bodies of saltwater play a vital role in regulating our planet's climate and shaping its weather patterns. Oceans act as massive heat sinks, absorbing a significant portion of the sun's energy and distributing it around the globe through ocean currents. These currents, driven by wind, temperature differences, and Earth's rotation, act like giant conveyor belts, transporting warm water from the tropics towards the poles, and cold water from the poles towards the tropics. The oceans also play a vital role in absorbing carbon dioxide from the atmosphere, acting as a crucial buffer against climate change. Let's dive into something you can't see but feel the effects of every single day: Earth's magnetic field. This bubble, our magnetic field, acts as an invisible shield, protecting us. The sun constantly emits a stream of high-energy charged particles, electrons and protons, known as the solar wind. The charged particles, instead of hitting Earth directly, are channeled along the magnetic field lines towards the poles, where they interact with the atmosphere, creating the spectacular displays of light known as auroras. This shield is generated deep within Earth's core, where the constant movement of molten iron, driven by the planet's rotation, creates electric currents. These currents generate a magnetic field that extends far out into space, forming what we call the magnetosphere. Without our magnetic field, Earth would be bombarded by the solar wind, stripping away our atmosphere and making life on the surface impossible. The moon is much more than just a pretty face in the night sky. It's a powerful force that has profoundly shaped Earth's history and continues to influence our planet in remarkable ways. Perhaps the most evident influence of the moon on Earth is the daily rise and fall of the tides. The moon's gravity tugs on Earth's oceans, pulling the water towards itself on the side facing the moon, and creating a bulge of water, a high tide. But here's the fascinating part: a high tide also occurs on the opposite side of Earth, farthest from the moon. As the moon pulls on Earth's oceans, the water on the far side lags behind, creating a second bulge. This rhythmic dance between gravity and inertia creates the twice-daily cycle of high and low tides that we observe along our coastlines. These tides create unique coastal ecosystems and affect marine animal migration. The moon's influence on Earth's tides is readily apparent, but it extends far beyond our oceans. The moon stabilizes Earth's axial tilt. Without it, our planet would have no seasons. This stability is also crucial for maintaining a relatively stable climate. Moreover, the gravitational interaction between the Earth and the moon is gradually slowing Earth's rotation. This process, known as tidal friction, causes the length of our day to increase by about 1.7 milliseconds per century. Over long periods, this slowing has been significant. Billions of years ago, a day on Earth was only about 6 hours long. As Earth's rotation slows, the moon is slowly moving away from us at a rate of about 3.8 centimeters per year. In ancient times, the moon's influence might have also played a role in the development of early life forms. Tidal pools created by the moon's gravitational pull could have provided the perfect conditions for chemical reactions to occur, possibly contributing to the origin of life on our planet. We've explored our solar system and beyond, finding planets that resemble Earth in size and composition. Some even orbit stars like our Sun in what seems like the habitable zone, but so far, none have shown definitive signs of life. Does this mean we're alone in the vast universe? Or are there other Earths out there, waiting to be discovered? Planets with their own unique stories, their own sets of cosmic coincidences that have led to the emergence of life? The truth is, we don't know yet. But that's the beauty of science, the quest for knowledge, the exploration of the unknown. The universe is full of possibilities, and the search for life beyond Earth is one of the most exciting adventures we can embark on. And there you have it, Earth's incredible features and the unique conditions that make it so special. It's truly remarkable how a combination of coincidences and specific factors have made our planet a haven for life. But what do you think? Are there other places in the universe that could rival Earth's uniqueness, or are we truly one of a kind? Don't forget to hit that like button if you enjoyed exploring Earth's wonders with us, and subscribe so you don't miss out on our next adventure. Next time on Solar System's Wonders, we'll be taking a closer look at our neighboring planet Mars. What makes the red planet so intriguing? And could it hold clues about our own future? Stay tuned to find out. Until next time, keep looking up.